Dave and I today are going to be presenting message-driven microservices in the cloud. Mostly, it's a new project called Spring Cloud Stream. So I'll introduce myself, and then you can introduce yourself, I guess. Although Dave needs no introduction, as we all know.
For the third time today, yeah. Hands up, who's already been in a talk with me today?
Okay.
All right,
who's been in a talk with me today? Trick question. Okay. Yeah. So basically, my background is with Spring integration, and then for the last 2 years, Spring XD, and most recently, for the last few months, the Spring Cloud Stream project and Spring Cloud Dataflow, which we'll be talking about today. They basically evolved out of XD. And
yeah. Okay. I'm Dave Syer. Hello. We can't hear who? Me or him? Nobody. Okay. I guess there's nobody at the back there. We just have to shout. Thank you for telling us. Yeah, I'm Dave. Dave Syer. I live in London. I work for Pivotal. And yeah, I've been working with Mark since, I guess, 2006? That's when I turned my head away, isn't it? That's the problem. Mm-hmm. 2006, something like that, on various things. So yeah, I started off with Spring Batch, actually, which was my baby. Anybody use Spring Batch? Good fraction, cool. Who used Spring XD with Batch? A few. Okay, interesting. And you know, I've always been a bit of a back-endy kind of guy. I didn't really play a huge role in Spring XD, except a little bit at the beginning when they were kind of just getting started, because Spring Boot was coming at the same time, and they were sort of both moving fairly fast. So I wanted to get my finger in that pie and make sure that the XD team knew about Spring Boot at least, and were using it as much as possible. And I think I achieved about 50% of that objective at the time. And so Spring Cloud Stream is in some ways me catching up with my technical debt of persuading Mark that, Mark Fisher and Mark Pollack actually, the Spring Boot was actually the way to do things, which everybody agrees with now. But at the time, you know, we were doing things independently, and not everybody could see what everybody else was doing. So it's going to be a little bit of a history lesson as well. I hope you don't mind if we indulge in that. We'll just tell a few stories about how we came to be here. But I think this is really exciting for me, right? This is a project that we've showed to people in various places, and it's literally the biggest smiles I have seen since I first showed anybody Spring Boot. This is, you know, if anybody gets this, they just get it. They totally buy into it straight away. So I'm quite excited by what we've started to achieve with Spring Cloud Stream, and the ways that it's starting to be used internally, and hopefully, you know, now we've released the first milestone version. We released 1.0 M1 on Saturday.
yes, a few days ago.
At the weekend. If you've seen Josh giving his talks, you've seen this Spring Initializer, start.spring.io. You saw it in the keynote last night if you were there. We'll probably have another look at it today, but it's already fully loaded with Spring Cloud bits, including Spring Cloud Stream, so you can try all this stuff out. Our slides are on Google, so we can probably make those available pretty quickly, but actually most of what we're going to show today, I think, is just code, because that's what Spring 1 is all about. And the code we can also put in GitHub, right?
Sure.
Yeah.
So after we write it.
Spring 1 2GX 2015 repo, not repo, organization. Spring 1 2GX 2015. All the code will be in there. Okay, so should we start?
Sure. Okay. With that, we're going to walk through a little bit of the background, as Dave mentioned, a little bit of a history lesson to describe how this project came to be and how it's related to Spring XD. Then we'll walk through some of the code and show some demos throughout. We'll be showing demos. We'll talk about what's happening behind the scenes, binding to brokers, and we'll look at how the boot configuration properties are used within this project, and we'll talk a little bit about partitioning as well when you're doing stream processing, and then the various runtime environments that are supported and how we support that. And a few slides on some composition, and then at the end, we'll talk just briefly about Spring Cloud Dataflow, but there's a session on that tomorrow morning as well. Okay, so for the history lesson, I guess I'm not quite sure what happened with this slide. It was an incomplete thought. But the basic idea here is that the things in green were things that were becoming more and more important to us. The things in red are some things that we're moving away from that were in Spring XD. And basically what we've done is decompose Spring XD. And one of the lower layers of that decomposition is the Spring Cloud Stream project we're talking about here. It really all started when we were trying to, we were heavily influenced by the idea of creating cloud-native microservices, and we wanted the modules within XD streams to be cloud-native microservices. We started working on a prototype to deploy onto Lattice, and what happened in that process is we realized that the original XD model, we had a concept of a container, the XD container. The XD container was like a bootstrap application context that would find modules and load them and start new application contexts. So it would set parents for the various beans that were needed, such as the message bus that those modules would connect to, and it would manage their life cycle. But this idea of a container that was running the code kind of got in between that code and the underlying runtime, and we started to notice that when we got onto Lattice. The XD containers were actually connecting to each other and communicating with the admin via Zookeeper. So the admin would know when the containers were coming and going. If something crashed, it would redeploy modules that had been on that container. And containers would set a node that they would watch in Zookeeper for requests to deploy new modules. And so we had this whole runtime based on Zookeeper and a basic coordination system across these containers and the admins. When we started running on Lattice, what we realized is that if we could just run the modules directly on Lattice, and the same applies for Cloud Foundry, then we could take advantage of the native health management capabilities of that platform. So and we could also...
Essentially what you've got is, there's nothing wrong with the Zookeeper pattern, right? It's just it's an elastic runtime. The problem is that we had an elastic runtime in an elastic runtime.
Right.
So it's a kind of a platform clash, isn't it?
Yeah, if you think of it that way, really what the health manager would be watching were these XD containers, but not the modules within the XD containers. We were doing that ourselves. So there's a lot of complexity that wasn't necessary if you're running in those environments and you already have a health manager. So what we ended up doing is taking the modules and trying to thin the XD container down, remove all the dependencies on Zookeeper to where you could run a single module in this sort of bootstrap process. And it got thinner and thinner, and actually I went on vacation. Dave and I were working on this. He got interested as he saw it getting closer to a microservice model. I went on vacation, and then a few days later, Dave had gone from the other end of the spectrum and kind of started from a clean slate, taking Spring Boot and Spring integration and building back up to the model. So we kind of met in the middle, and that was when we realized that this was the way to really make the modules themselves as fully capable as boot applications as we could. And originally we called that Spring Cloud Bus. If you're an avid watcher of our GitHub repo, you would have seen a Spring Cloud Bus project for a while. And then we realized that bus wasn't quite the right term for that because it implies some kind of central server. And really what we're doing is just within the app, we're binding to a broker. And you'll see this when we get into the programming model. And so we're basically facilitating the implementation of microservices for processing data, right, in a streaming way. And so we decided to call the project Spring Cloud Stream. There's a sort of sister project now, which is also part of the decomposition of XD, called Spring Cloud Task, which is related to the more like native boot approach for actually running jobs that are task-oriented as opposed to stream processing. So
short-lived.
Batch jobs, short-lived tasks. Exactly.
Lattice supports short-lived tasks sort of natively, which is kind of where it first piqued our interest, I suppose. Yeah, I don't know, maybe I can just explain my approach to the whole thing. So Mark described me as coming from the other direction, and we met in the middle. It's a little bit more complicated than that, and to me, it's part of the story is a sort of a social one. because it actually all just gelled. It all just came together like almost like fireworks or something. Something exploded. Because we were both, I think, both kind of thinking about it and both kind of uncomfortable with the way things were. And I wanted to have message-driven microservices. I mean, that was the goal, right? I wanted to just write a Spring Boot app and make it listen for messages or make it send messages without any rigmarole, right? No configuration, all convention-driven, which is very much in the Spring Boot spirit. And I didn't see why that would be so difficult. And I kind of sensed that there was something in XD that would help me. And then Mark and I spent a week together in Cambridge in Massachusetts back in, when was it, May or something?
May.
And then you went on vacation, right? So he gave me all these ideas. So he showed me these demos. He got a lot further than I did originally. But then he inspired me to go and look at what I could do from that angle. Just with a Spring Boot application, I want to bind to some message queues, but I don't care, right? I don't want it to be a central. I don't want it to be a bus. I don't want it to be anything central. I don't care what the transport layer is. I really don't. I just want messages. You could think of it as sort of MIME types for events or something like that. I just want, content types and domain objects and things like that. That's what I want to deal with. And the Spring integration and Spring MVC and the Spring Stack has enough nice programming models for that sort of stuff already. The only thing that's missing is the glue, right? Just making sure that I can call a method. Let's say I want to execute a Java method on an interface, and just take the argument from the method and just send it as a message. And I don't care what happens to it, because that's what messaging is about, right? It's all decoupled temporarily and in a sort of business sense, decoupled. So actually, probably the next slide is going to help us to explain that a bit. This is the before and after.
Yeah, and I think before we jump into the details here, I think it's worth pointing out that what we've accomplished is basically something on the Spring integration side that maps very closely to what everyone's gotten used to now with boot applications for Spring MVC, right? You use request mapping as usual, but you create a boot application so the container is embedded, and now it's an executable jar, but it's also portable because of boot property binding. You can run it in many different environments. So we basically wanted to expose that same model, but instead of the request mapping, you use any of the Spring integration annotations for your method. And you end up with, I see it as sort of the next step of message-driven POJOs that was a big deal when it was the alternative to message-driven beans, but now it's actually message-driven microservices as applications. So what this slide shows is really this idea that the container has been taken out of the picture, and therefore the coordination of those containers is no longer the responsibility of our own built runtime with Zookeeper, but an SPI layer that's responsible for that. So when we're running on Lattice, we hook into what's called the receptor API, which is the REST API above the Diego runtime inside Lattice. When we're running on Cloud Foundry, we hook into the Cloud Controller REST API. When we're running on Yarn, we use the Yarn programming model for application management there. And when we're running locally, we have a single node option where we actually launch those boot apps within the same process as the container if we're building a Spring Cloud Dataflow. But each of these boxes with an M on it is also just a boot application that you can run as Java-jar. You end up binding properties and things that Spring Cloud Dataflow would do for you, but it gives you a much better experience for the full development lifecycle and for testing as well. And so this actually shows the sort of project structure that we've arrived at now from the XD side. And obviously the focus of today's talk is the Spring Cloud Stream box itself. But like I said, Spring Cloud Task is the corresponding model for the short-lived processing. And then above that, what we're doing is we're basically taking all of the modules we had in XD and we're porting them over to this new model. And so we're going to have at least as many, and since the development model is actually simpler, I think we're going to have a stronger ecosystem there and a lot more community contributions as well. So right now we have a Maven repository where we have the beginning of those migrations in the Spring Cloud Stream modules repository. And then Spring Cloud Dataflow is just an orchestration layer. The interesting thing here is that the REST API, the shell, and the DSL that you use through the shell is all backwards compatible to a pretty large degree at the Spring Cloud Dataflow layer. So again, there's a talk on that tomorrow morning, but you can start up Spring Cloud Dataflow, and it's actually profile aware itself, and will detect whether it's running on Lattice or on Cloud Foundry or locally or with Yarn, and the corresponding SPI will be wired in automatically. The admin is itself a boot application, and then it will just be deploying these modules as boot applications itself. Okay, so Spring Cloud Stream, I guess the simplest way to look at it is really, as I mentioned, bringing Spring Boot to Spring integration in the same way that we have already for Spring MVC, but also bringing in capabilities from Spring Cloud. So for things like configuration management, you can use Spring Cloud Config Server. To locate services, you can use the service registry, and so on. And this is what the programming model looks like. So here we have on the top a source. The @enable binding annotation, this is the part that looks like boot, right? You get used to seeing all these various enable annotations. They bring in configuration that does something for you. In this case, what it's going to do is detect what binder implementation you have on your class path, and then use that binder to create channel adapters. The source itself, I think on the next slide, I'll come back to that slide in a moment, but this just shows you what the source is actually providing. It's just a message channel interface, right? So it's similar to in some ways as the Spring Cloud Data repository support, where you implement an interface, and then the underlying Spring code will provide a concrete implementation of that for you that you can use in your code, and you just inject it in. So that's what we're doing here. In the top one, we're just using the channel name inside of the inbound channel adapter annotation. And in the bottom one, we're using it inside of a service activator where we consume the message. You could also just auto-wire the channel that is now provided through the source or the sync interface.
So that might just be worth explaining exactly what those two apps are going to do. There's two apps here, and I can launch them both independently, separate processes. The one on the left, the source, is an inbound channel adapter, which is a little bit of gobbledygook that, for me, just says Spring integration is going to be calling that method every second, is what's going to happen. And if I wanted to change that, I could add a poll declaration to say, call me every day, or call me at 9 o'clock on Saturdays, or something like that, right? So that's the top bit, is the source, because it's generating messages for Spring Cloud Stream. Those messages are going to go out into the ethosphere. We don't actually care where. The default's going to be Redis, probably for the demos that we do today, I mean. But that just depends on what's on the class path. That's the Spring bootiness of it. And then on the right-hand side, you've got the sync. It's a separate process that's running over here. Maybe it's scaled up, right? Maybe I've got 10 of those processes running. They're all listening to another middleware integration channel, whatever that is. We'll show you in a minute how you hook them together. So there's just a naming convention they have to know about. They have to agree on what the name of the queue is going to be in the middle. But we abstract almost everything away apart from that. So they're just going to have to configure. They're going to have to agree on some configuration. And actually, that's what XD, Spring XD next generation, so Spring Cloud Dataflow, is to a large extent just handling things like that, right? Just hooking things up and not leaving it to the developer to decide what the names of things are. Mm-hmm. So on the right-hand side, we've got a sync, which is therefore just it's just service activator. It's just a message comes in, and it activates this method and prints out the message. Couldn't be simpler.
Okay, and this is just showing the @enable binding annotation itself. It accepts the value is an array of classes where those classes are actually interfaces that define channels. So in this case, we're using source and sync, which are provided out of the box for the simple case where you have a single input or a single output. But you could also implement your own interface that has a dozen channels in it, and then use that inside of enable binding. And what we'll end up doing is taking each one of those channels and creating a channel adapter for you and handing the channel instance to the Bean factory so that you can inject it into your code and use it. And the names will match what you have in the method names or via annotations. which is what you see here.
Yeah, and you can see here the at input and at output are the annotations that you add to the methods. So, for instance, I could have an interface here called, I don't know, might take my demo this morning with Josh. It could be called reservation service channels. And then you could have two methods in it, one input and one output, with two different method names, whatever you like. And then basically what Spring Cloud Stream does is it introspects that interface, looks for all the methods that have a message channel as a return type, and just create not just a bean definition, but also a whole infrastructure binding to the external message queue, stuff to do with message conversion, headers, all of that stuff. Somebody was asking about the headers the other day in a meeting. So it's very flexible, it's very powerful. We argued a lot about what this would look like, but I'm very happy with the way it's ended up.
So am I. So I don't know why we were arguing. The other thing here is that even though this is showing just source and sync, as we've mentioned, you can have multiple channels. So this is another part that's different. In the XD model, it's very opinionated. So that's still the same for Spring Cloud Dataflow, where you would create a linear pipeline. And so each module is going to have an input and or an output, a source and a processor and a sync.
This is the XD model. There is actually also an out-of-the-box interface called processor, I believe, or there was last time I looked, which is both a source and a sync, and that's basically what you get in XD. So in XD, you have three kinds of module, or more than three, but source, sync, and processor are kind of canonical, and that's mirrored here in the interfaces.
But this opens the door to a lot more possibilities if you're working directly at this layer, because you can have multiple channels. And so you have multiple inputs and outputs, and you can create more complex flows than individual pipelines. You can even use the multiple channels along with XD as long as one of them is input and one of them is output. So those end up being used as the bindings. But you might have another kind of side channel for interaction. So it's actually allowing us to make XD itself a little bit more flexible in terms of what the modules can do. Okay, and this is the same example rewritten as Groovy, because Dave has this obsession with being able to build an application that could fit into a tweet. And I think both of these, the last we checked,
both of these are
tweetable apps. So if that's important to you. We were talking about building a module that would be a source itself that can register as a subscriber for direct messages on Twitter and then launch these modules when you tweet them to that. So that could be a new form of deployment.
Do you want to just run that?
Yeah, let's run this example. So we've been talking long enough, right? Okay, so I'll just show you here. We have that exact same code. There's the logger, and here's the greeter. Right, and I guess what I'll do is start Redis. Okay, so I'm starting up Redis, and then
I'm going to start the CLI.
Over here, I'll start I'll just start the CLI here so we can see it on one screen. Can't type today. And I will use.
Monitor, or you going to do a monitor now?
Sure.
Or?
We like paired programming as well.
We do, yeah.
Okay, so I'll start. Actually, let me start the greeter, since that will start emitting messages, hopefully. I didn't use the binding, but we'll see that, and I'll restart it.
There you go.
Okay, so what we see here is it's emitting hello world, and the queue name in Redis is queue.output. That's the default name because that's the channel name of that application. I want to use something that I can, it's easier for me to share with the other applications. So we'll just say this is minus Spring, Cloud Stream, bindings, output. Okay, so that maps to the actual name of that channel that's being created for me. And I'll call it greetings. Okay, and then on the right-hand side, we should see the messages start coming to a queue called queue.greetings instead.
There we go.
Okay. Now I can start the logger down here.
Yeah.
Gun. I have that. And we'll do the opposite. So Spring Cloud Stream bindings input equals greetings.
Wait, server.port.
Oh, yeah. I like to make...
It'll die. Okay.
Just to show that it's a real demo here. This is going to crash because I'm running...
It's still getting the messages, by the way. Did you see that?
That's interesting. Yeah. But it failed to establish the Tomcat connection because they're both using the default in boot for port 8080. So by setting that to port 8081, then I get both applications with their
a Spring Cloud Stream app. I don't think it needs to be an actuator, but this is the Groovy CLI, so we're opinionated, and by default we make everything which is a Spring Cloud Stream app have the actuator endpoints. Okay, there it is, pumping messages.
Okay. So that's using the Spring CLI. And I guess what we could do is build one in STS as well.
Why don't we build it in STS, yeah.
Okay, so I'll build one here, which will also allow me to show off a few features of some of the latest features of STS. For one thing, we have the support in STS for creating starter projects. Has anybody used this? Yeah. It's basically a wrapper in STS for the initializer. You saw it in the keynote last night if you were there. And we can, I'll probably call this demo source. How about? Okay.
Didn't like that name. I think you've already got one called that.
Yeah, I'm sure. Call it HTTP source, and we'll I probably have one called that too. No. Okay. So what I'll do here is a little bit different. Instead of a polling adapter that's just emitting a message every second, I will create a REST endpoint that could be the entry point for messaging. And we'll use boot 130M5, and we can choose Rabbit this time. Why not? Well,
Rabbit running.
no, I'll use Redis, and then we'll switch, and I'll start Rabbit. So we can talk about that. So stream Redis. Okay, so this is basically what we had in the Groovy version by default as well. Spring Cloud Stream Redis. Anything else I need to select here?
I don't think so. Try it.
So a bare bones application here. I probably should have included web if I'm going to make a
Oh, if you're going to be a REST endpoint, yeah. Let's see if it's there.
Okay, so this is my entry point. It's a Spring Boot application. This font's not great, sorry. I'll increase the font size.
If you're using the STS from Martin, there's actually an Eclipse plugin already doing that.
Okay.
Oh, that works.
That's a little better. Okay, so it's a boot application. This is the entry point, and there's really not much else here, but I can create a new class called HTTP source. And we'll add enable binding. Nice. What just happened? Okay. And this is a source. Okay, so as I mentioned earlier, using this annotation means I can actually just inject the channel. Using AutoWired. Because all that's happening with this is that the classes that we configure through enable binding actually detect what interfaces you've defined here, and they create those channels for you. And in this case, since Redis is on the class path, we look at the POM, I added that starter for Redis. They're going to create Redis channel adapters behind the scenes. And later I'll switch this to Rabbit, and we'll see that that's the only thing that has to change for us to use Rabbit. As opposed to the normal Spring integration approach where you would create your own channel adapter and then give it the name of the channel that it sends to. Okay, so, yes. Right, for multiple transports. Yeah, we've talked about that a little bit.
We talked about maybe being able to do that, but then you'd need to, you just need to configure the channel binder separately. So there's a channel binder abstraction that each of those implements, and at enable binding just makes one of them. You're going to need two, and you're going to need a way to tell each one which channels to bind to, right? So we don't have an answer to that yet, but I think it's it's
one of the things
not
that we've
problem.
discussed is having a transport option on this annotation, so that the interfaces that you're bringing in with this annotation would have that binder applied to them, and then you could have multiple instances of enable binding in the application.
So I have to go to the channels. How do you read and write external sources and sinks? That's what we're going to do here. Watch.
Okay.
Do you need to qualify the auto wire? I think it's that output, isn't it?
It should work.
Should work, shouldn't it? Okay.
Yeah.
You don't get the error channel. And
Okay,
you probably
so
need that configuration on the top of the class then.
I don't think so.
Do you? Okay, fine. So this is going to be a request mapping, is it?
Okay, we'll find out.
Okay.
I'm sure I left something out. Okay, so what I'm doing here is I'm just using the message builder with payload. And this time we'll say hello to whatever name is provided. Okay. And this needs to be a request mapping. That brings it into starter for me, right?
Oh, yeah, probably.
Okay.
Unless if it wasn't there already.
And we could do /messages. And this should be what, path. And request method. If we post, okay? So another thing I can do is use Spring Boot's support for application properties. And here what I can do is specify the server port. So let's say I want to use 9000. Okay. I can also specify the Spring Cloud Stream bindings. And notice I get auto-completion here in the editor. Output equals greetings. Okay. Did I forget anything?
I think.
Request body on the parameter.
You need to add REST controller, all that.
Oh, yes. Okay, two things.
Yeah.
Two more annotations.
I think that needs to be app configuration as well, but you could prove me wrong.
I'll try.
And that needs to be a
Request body.
request body.
Okay.
So, how are you going to send oh, okay, you can send a string as a request body, can you?
String.
How are you going to send it? Oh, you're going to send it with a
We'll just
browser
post.
or something.
Yeah. Okay, so that is now a Spring MVC application that also happens to be a Spring Cloud Stream application. And this is something that wasn't really possible in the Spring XD model. Right?
Did that answer the question that you had? Does that sort of answer the question that you had? It's simple to... Yeah, that is an HTTP source. Yeah. Oh, you mean there's already an out-of-the-box one that does that? Yeah, okay, fine. But I mean,
right.
You can obviously see that we can make this more complicated and... Yeah. So we can...
Yeah, so, I mean, but that's an interesting point. The HTTP source that we have in XD today that we've migrated over to this new model is pretty similar to this here.
To that, yeah.
There are other things that we can add to it. It does have the path as a configuration property, so you can specify that with -- path and make that configurable. There are other things that we'll do to make it more configurable, but it's very much of a single purpose, like this is to act as a gateway between an HTTP request and some message broker. But this now, as just a simple addition of a starter when you're building the application and using this enable binding annotation, means that any web application that you're building can also now become either producer or consumer or both for messages as well, pretty easily.
Okay.
Without requiring a lot of boilerplate. So what's next? We need to run it.
You reckon that works?
Okay. So I'll use the boot dashboard here to launch it. And Dave thinks it's not going to work. Is that right?
slightly worried that you won't get the app enable binding because it's not app configuration. You'll get an endpoint. Did it start any?
There we go.
Oh, it did.
Started.
Okay. I'm wrong.
So, and I'm using server port 9000, so we should be able to see the boot actuator here, so you can see my environment. And we can see
If you look at the metrics, you might see the message channel metrics as well.
You see the beans
Yeah.
and the metrics.
So some integration,
Somewhere.
look at integration channel output send count 0.
Right. So a lot of stuff that you get here for free because it's a boot application, and these message channels are already exposing metrics, and now they're being brought in there. Okay, so that means, let me stop this app that was emitting messages. Nope.
Yeah, that was the one.
Oh, it's popping. Yeah, sorry. Okay. Okay, let's see. Just clear that out. Okay, we'll monitor this again. And now what I can do is just curl. We can specify content type.
Okay. Text plain.
Do that. Now this is supposed to be a name, right? And then localhost 9000. What was my path? Messages.
Messages, was it?
Okay.
Yay.
There we go. And so now it's going into Redis. We don't have a consumer application, but it's on greetings. We actually should have kept the logger running. Just run it here. Let's see if it's... And then do that again. Should have used a different... Okay, so now the logger, the Groovy version of the logger is running again, polling Redis. And
Yeah, I was thinking.
localhost 9000 messages. Okay, and there we have hello Dave in the log. Okay,
All right, let's move on.
back to some slides. Okay. Okay, so what this is showing is basically what you just saw. We were running it through the boot dashboard, but could just as easily do java-jar, like a Maven package of that application, and then java-jar, and then you can pass either -- arguments to that, or you could pass system properties or environment variables, any of the supported property bindings for Spring Boot. And, nice. As we mentioned, the starter that we added could be swapped with something else. So I think that might be worth doing next, is to swap from Redis to Rabbit, just by changing that starter. So this shows right now we have support for Kafka and Rabbit and Redis. In a few minutes, we'll also get into the composition of modules, where we actually have the ability to do direct binding between modules if we run them together. And that way, you can basically take this logger and greeter and run them in a single app, even though they're separate boot apps, and we can fuse them together so that one receives its output channel that is the other one's input channel. So they're actually sharing a channel in that way, and you don't have any network hops. So you can build these compositions, and that's something that we'll be doing with XD to effectively do module composition or co-location of modules where we can short circuit the network hop. Okay, so let's just swap that out in the POM here. We'll change this to Rabbit. And I will start Rabbit. And get that out of the way. And let's see, I think, where am I in this workspace? Yeah. So again, I can just run Maven clean package here. This is the project. If I'm not using the IDE, for instance. Okay, and now I can do java -jar and the, what is this? I didn't change that in the starter. So I can run demo jar, Spring, Cloud, Stream, Bindings, Stream, dot. I'm having trouble with punctuation today.
That's right. Try an equal sign, why not?
I'll call it foo this time.
You want a server port as well, or are you okay with 8080?
Why not?
Oh, it's in the application YAML, isn't it?
Yeah, it is.
Set that 9,000 already.
Okay, so now this should be sending to Rabbit.
How do you know if it's sending to Rabbit?
Well, it didn't because it failed. Oh, I'm
complex.
It is still running the other one, huh?
Still running in there. Yeah.
Okay. So that was running on 9,000 as well.
No demo would be complete without Tomcat and a port conflict, right? Tell me if you see one.
Okay, so that started the HTTP source application, and then I think here I have my local Rabbit UI. Let's see, binder.foo.
That's the queue.
And
we haven't sent anything to it.
We haven't sent anything, right? Okay. I should have
copied that.
I should. I will next time. You could tell jokes.
I don't tell jokes.
All right.
What's that, Gary? Right. Say Gary.
Okay.
Gary already started in Josh's presentation.
Okay, so we should see one message.
Yay, a message.
And get the message. And wait, what did I just do? I just closed that instead of hitting that. And it says, hello, Gary. All right. So that's how easy it is to swap the binder. We can switch between Redis and Kafka and Rabbit.
Which
And we will have other implementations as well, like JMS.
It wasn't like you couldn't do that before, right? It was just, it's a Spring integration application, and it's got two profiles, roughly speaking, and you switch the behavior depending on whether you want to use Rabbit or Redis, but it's just a lot of yak. And we just shaved it, basically. You don't have to shave that yak ever again. I feel quite good about that, having done that a few times. Okay.
Okay.
So then, so the other thing, if you're really buying into Spring Boot, then you get all the Spring Boot features, right? So at configuration properties, one of the most useful and, highlighted features of Spring Boot, binding environment properties into Java objects. And, so we can just use it, and it's natural. Everybody can read the Spring Boot manual. Nobody needs to understand something different. We just, create a time source properties object here. It's a strongly typed domain object. So we can bind a data format. We can bind, anything we want into it. That's it, really, isn't it?
Right. Yep. And this, actually, I'll just show this where this code was taken from because there's a little more to it.
Mm-hmm. This is the way that the Spring XD modules are all being rewritten.
Yeah. In fact, let me just open this up.
That was actually the biggest impedance mismatch, I think, because the thing that I came up with when Mark was on vacation, I could run existing XD modules, but I had to do a translation. I had to do a bridge for the options. They called it module options, and they weren't quite configuration properties, so I had to bridge it. What was the problem with the direct channel approach? So if you define an input channel and an output channel, that's called a processor. And that's still something you could do here, right? You could have a processor interface with two message channels. Well, it's actually, okay, so why do I think this programming model is more effective than the XD module one? It's actually essentially the same, except this configuration properties thing, right? So the impedance mismatch was just that, really. The thing that's more powerful about it, though, is, so that's the difference. The difference is module options and configuration properties weren't the same thing, but now they are. And the other thing that's different is it's more flexible, right? So you're not restricted to 1 or 2 channels. You can have as many as you want. You can have as many inputs and outputs as you want of any kind. They don't even have to all be message channels. So that just gives you a lot more options. If you want it to be an XD module, then it has to have a channel called input, a channel called output, or both. But that's the only rule.
Right, and I mean, we can easily support something like aliasing, so even that requirement wouldn't be
and even that wouldn't be
necessary.
So this is question in the middle there. Might as well take that.
Sure.
How does this relate to Spring Cloud? I think of Spring Cloud as centralized configuration, discovery,
Yeah.
all that sort of stuff. You're launching a very lightweight thing, but it's like scaling or failover or looking discovery. None of these are doing that.
How does it relate to the other Spring Cloud features? I think in a nutshell, it's really just the fact that Spring Cloud is or aims to be like the best place to build microservices, okay? Small pieces of distributed systems, and that definitely qualifies. Spring Cloud Stream is a different kind of microservice than the other ones that we've been building, but it's still a microservice. Discovery, probably not terribly relevant in this unless you want to make a REST call. But you still have that option, right? I mean, I take your point that some of these features are maybe a little bit orthogonal, but I think the spirit is there, and basically it's to do with building distributed systems without shaving yaks. I mean, that's really what we're here for.
Yeah, cloud config is one. I mean, obviously it's the most general purpose probably, but it's definitely relevant for the setting of these properties to be able to use that. And the service registry as well, I think, for these applications to be able to register themselves so that even if it's just for the use of their actuator endpoints, that's something that is going to be increasingly important when you're running these as the modules inside of what is now Spring Cloud Dataflow, but XD 2.0 basically, and you're running in a cloud environment with a lot of modules. Okay, so this is the actual HTTP source as it exists right now in the new code. And you can see here, it's very similar to what I just wrote. We have a path pattern as something that you can specify. And we have the enable binding on the source. And, well, the HTTP source is not the one that we were showing in the slide, right? But there's that, okay. Time source is the one that we were showing in the slide with the properties. Yeah, so this one has enable configuration properties, which brings in time source properties. And if we look at time source properties, it's just the format, right? And this does have an annotation here for date format, which is a way to extend the validation of a field as well. And you can also use JSR 303.
I think it's 303.
Annotations for validation. The other thing this is doing is actually importing another configuration called periodic trigger, which any source that is polling based and wants a periodic trigger can import that. And that comes from a common project that we have here. And this shows how it's a pretty powerful model when you start composing applications with properties. Because this one is itself enabling properties called periodic trigger properties. And now these properties, fixed delay, initial delay, and so on, are available. You've basically inherited them in that time source module because it's bringing these in from here. Okay.
We've got half an hour basically.
Okay. Okay, should we add a property to the greeter?
Yeah,
No?
do the Do the big demo. I like that.
Okay. What's the big demo? Okay. You mean this one or the with the cloud data flow?
I wanted to see the cloudy bits, but
The
you know,
which?
have time for that Cloud Foundry or
Yeah, we can run it, yeah. Okay, so this is showing partitioning. This is basically, I don't know if that's very easy to read.
it's a bit crappy, isn't it?
But again, they're just properties that are being passed into they're boot properties that are being passed to the jars. And what you can see is that the bindings have, in addition to being able to specify the name of the corresponding channel on the broker, you can also pass other properties that are relevant to that binding, whether it's in the role of a producer or a consumer. So this top one is a producer, the HTTP source, and it has a partition key expression. And you could use any spell expression that you want there. In this case, we're just going to partition the payload itself. And so what that means is it's going to, by default, use the hash of that object and then do mod in, where in is the value that you've provided here for partition count. So in this case, it would create two partitions, or it would be sending to two different partitions, and then the two subsequent modules are the consumers. And each one has an index assigned to it. These values are assigned here manually. If you're running inside Lattice or Cloud Foundry, then the instance index would already be available as part of that module. If you scale up modules, each one gets an incrementing index value. And so those will now be consuming from those two partitions. This starts to show an example of where the Spring Cloud Dataflow is still very useful at the level of a DSL, because if you do partitioning in the DSL definition, it's just like in XD 1.0, where you specify the partition key expression when you're deploying the module, and then we will work out all of these other values and pass them along when we launch the boot apps inside that runtime. Okay, so I can skip that one, I guess. No?
We'll come back to it if we need.
Okay. So obviously, one of the biggest benefits, and as we mentioned in the history lesson at the beginning, one of the main motivations for this new direction was to be able to have runtime portability at the level of the application itself, to be really cloud-native applications. And we get all of that really just from the fact that these are boot applications. You've seen the examples that I've been running. I haven't had a processor, but we could have had a processor between a source and a sink, just running with Java minus jar. We can run inside Docker containers, so you can do Docker run. I'll just show an example of even the Docker compose, right? We have in Spring Cloud Stream samples, right? Let me see. Yeah. So this, that's
What size?
not much.
Bit of a simple one.
Where am I?
Is it the module samples instead of the stream samples?
Maybe so. Anyways, I thought it was there, but I guess not. So the Docker support is basically just passing in boot properties as environment variables. You don't have to worry about ports in that environment. You won't have Tomcat port conflicts because each container would have port 8080 inside, and then it would map it to something outside. So you usually do pass a port mapping so that you can communicate with it. I don't know if you want to talk about any of these boot features here in this context.
I mean, I don't know how compelling this is for anybody, but I mean, you could any source of properties will work, right? So if you wanted to, you could use Jindy. You could run one of these things in, a WAR file deployed on WebSphere if you really, really want to. I wish you wouldn't, but if you really, really want to, then, because it's just a boot app, I think that's the flexibility message that we want to get over here.
Mm-hmm.
And we've got a couple of things, that we do kind of because as Spring Cloud Stream is basically a Spring Boot plugin, so, it enhances your application when you include it. So it does things like, looks for profiles, like it behaves differently if you have a Spring profile called Lattice active And the Spring Lattice profile itself is activated by actually the connector, right? The Spring Cloud connector for Lattice. So everything starts to work together in a transparent yak shaving fashion, basically. So you don't, as a user, you hardly have to know about it. It's nice to take comfort in the fact that you can control it if you need to, but there's so much that we can do for you. It's every day we turn over a new rock and then there's another yak just crawled out and we can shave it off for you. It's just a Spring Boot app. That's really the message in this slide.
Okay, so let's see if we can.
So the next thing we want to do is to show you the sort of range of options you've got for deployment. So far we've just been running Spring. You can do the demo if you want. We've just been running Spring Cloud Stream apps as standalone apps, various different ways. We had a Groovy script. We had a running from inside the ID in Eclipse. We had a Java minus jar. We could have done Maven Spring Boot run. We could have done the Gradle version of the same thing. And all of those things are then just independent processes, but coordinating through a naming convention or message channels. If you want to get a bit more serious and scale things up a bit more, maybe we can think about some of the other deployment options we have. So really what you're looking for is a platform, right? And maybe it's a service or maybe it's not, but it's a platform. You want to take your bytes, your jar file that you just made with Spring Boot and make them run. And we know of a few platforms like that, right? We know of Cloud Foundry, which is going to probably be part of the demo in a minute. We also know of Lattice, which is kind of Cloud Foundry's little sister. We also know of Yarn, right? And Spring XE always ran on Yarn, and so does this stuff, because basically we're just using Yarn as a scheduler. And anywhere where you can get scheduling, you can run Spring Boot apps. We've got a story. So Docker Machine on AWS or ECS on Amazon. Those kinds of things. They're all probably more yak shaving than running it in Cloud Foundry, but you've got so many options now. It's just a boot app or just a system of boot apps, and they're all just glued together with message channels, essentially. So what are we doing now?
So I was thinking I would just run this HTTP source on Cloud Foundry, but we add the Spring Boot starter for cloud connectors.
Okay.
And do I need anything else?
What does that do? Does that connect to the Rabbit for us?
It should if we add a manifest, right?
We need to create a Rabbit service and bind to it.
Right, and I probably need to set a new target so that I don't use the Keynote demo. Right. Okay, so
so it's actually, this is the first time we've seen this. A new STS tooling piece where he's just creating a new Cloud Foundry target and showing you how easy it is. Credentials. With the credentials, it can authenticate and it can go and find a list of available spaces, assuming that Mark can type his password correctly.
I'm using the wrong user.
There we go. So there's a list of available Cloud Foundry sort of tenant spaces.
Okay, let's see. So I do have Rabbit already running in my space.
So you just need to bind it to this app.
As long as I don't have, okay, I have no apps running in my space. So yes, in order to bind Rabbit to this app, we should just add a manifest.
Probably one of the ones that we sampled the other day, I guess.
Yeah,
Quickly.
I've got some from the demo.
Any of those.
One of these. Manifest. Okay. Okay, so this one just needs Rabbit, and we'll call it HTTP source. Should be good. Rename it. Yeah. Okay, so this is a manifest YAML, which is what Cloud Foundry is looking for a number of things, but in this case, the most important one is the binding of the Rabbit service that we have running in this space for Cloud Foundry, which should allow me to hit that with the HTTP source for the binder. I'll go back to the dashboard. And too many apps. Take HTTP source and we'll drag it. No, that's not dragging. Onto that space.
Cool.
We'll see. We didn't rehearse this demo, actually.
You told me you've done it before.
I've done it before, but can't remember if I left out a step. Okay, you can see here it's actually uploading the archive to Cloud Foundry. I can run Spring Cloud Dataflow maybe on Lattice so that we see that.
20 minutes if we need it. Any questions? Well, 2 minutes we've got while we're waiting for that. Yes?
So a little bit about the new application will be like that Dataflow, which can make a very pleasant small business. Will it have, for example, ability to test to the
Okay, can we say more about Spring Cloud Dataflow, which is it's basically an evolution of Spring XD. It's XD 2.0, and so I believe that it's pretty much backwards compatible with Spring XD 1.x. So therefore, taps as a feature of Spring Cloud Dataflow rather than a Spring Cloud stream, because really it's just a set of new channels and channel interceptors, which in Spring Cloud Stream I could set up myself as a user. It's quite easy to do, right? I just add a bean of type channel interceptor and annotate it. So what the Spring Cloud Dataflow is doing, what XD is doing essentially, is making that kind of a declarative option. When you deploy a module, you can say that you want to tap it. So that the same feature set basically is going to be preserved. You should go to, it's tomorrow, is it the Dataflow talk?
Yes, at
First thing
8:30,
tomorrow,
first
yeah.
thing in the morning. Yeah.
One more. Right. Yeah. So with Spring XD, there are some built-in plugins for instance, export. There's a sync which is to HDFS. That's what you're talking about, right? So how do you do that? Exactly the same way, right? So the all of the Spring XD modules are pretty much already ready for this model. They just have to have their configuration properties mapped, because they're really just Spring integration configuration snippets, right? And they've just with some naming conventions, so it's pretty much identical. So I'm not sure if that's been done, because Thomas is in the room. He was doing it. Have you done the HDFS sync yet?
Yes.
Yes, so it's already done. There's a Spring Cloud Stream Modules repo on GitHub.
Yeah, that's what I have here.
existing
So
ones.
you can see the HDFS sync is also
Oh
in
yeah,
that
so he's
repo.
got it checked out here. Yeah. Well, it's a module. It's a jar file, and so in the new world, it's a runnable Spring Boot application, for instance. But you can also have Spring Cloud Dataflow deploy it for you as an app, and that's kind of what the Dataflow layer does on top. Mm-hmm. How do I send a message to XD? Sending a message to XD is the same as sending a message to Spring Cloud Stream, right? But they use the same channel binding, and then it's just a naming convention on the channels, basically. It's as transparent as it can be. If we need to clarify that, we can talk about it afterwards. Is it working yet?
It's running.
Yeah.
I mean, I hit it here with the env, and we have.
Okay. So we're
cloud
running in the
profile
cloud
enabled.
profile.
We see all of Rabbit. The only problem is I was going to add the log so we could see the results out the other side without having to go through.
Oh, okay. So yeah, you're going to run that as an app.
Yes.
Okay.
But I actually want to restart that one with the server, the binding, so that we have a name that makes sense as well.
Right. So it's not just called
Right.
output.
So,
I like output.
Okay. Oh. It's fine once it's on that side, but not on the other side.
Yeah, because on the other side you have to say spring.cloud.stream.bindings.input equals output.
Oh, no, that still had, I think, greetings.
It works.
Input, greetings, okay. And then the manifest here will be, so I just copied it and redid it as log sync. And so now it's basically what you saw on the slide. It's going to log messages that come in on the input channel. This is now sync instead of source. The application properties, this is now input instead of output. Server port doesn't really matter in this world, so I can remove that, yeah.
I'll leave it in case you want to run it locally, right?
Yeah, I'll change it so it doesn't
Yeah.
conflict. And then the manifest, sorry, that's the wrong. Manifest here, application name is log sync, but that's also going to bind to Rabbit, and that should be it, right? Okay. Drag that.
You've already rerun the Rabbit one with the binding change, name change.
No, I didn't need to because it was in application properties. Greetings.
Already, right.
Yeah. What I do need to do though, because even though you told me to, I still didn't copy that. Get this ready to go. Who can we say hi to now?
Yeah, it won't take you 2 minutes to do that, right?
It's starting up anyways. Let's say hi to Eric. And I need to get the URL. Okay. So one nice thing about this boot dashboard is you can look at the properties on the app. You can see the URL here. This doesn't have any. My console.
Open it in a web browser and it will get something you can copy paste then. Right click. Right. Oh yeah, that was that. Yeah.
I was trying to show.
That lets me unreliable. I should just right click on there and open in web browser and then you'll get the host name with you.
Oh, okay. Oh, yeah, sure. This is the log sync, right? So.
Doesn't have a home page. That's not actually an error.
Yeah.
Yeah, sure.
So you said allow integration from integration JavaScript integration and kind of things more general. Why not take integration from the messaging, the administrative messaging APIs like we have for JMS and Rabbit?
Okay, so we took a lot of inspiration from Spring integration and Java configuration of that. Why did we also take some inspiration from annotation-driven JMS and AMQP and those things? Is that what you were talking about? Yeah. Right. So I guess, right, so the question really boils down to, is there an annotation I can add to a method that just says, bring it here, do it now? No, there isn't. Maybe there's room for making that a possibility. I think that what we wanted was to keep as much flexibility as we could with the multiple inputs and outputs, right? So the problem with an annotation would be that it would then become anything that you wanted to do to make it more finely grained would then be quite weakly typed because it would just be, the annotation attributes. And so that's what I like about our interface approach, that it's quite sort of strongly typed. Yeah, property placeholders are always a possibility. They're always weakly typed as well, though. So I mean, I don't think I'm ruling out ever having a single annotation approach to writing a message consumer, but we're happy where we are for M1, put it that way. I mean, it's an annotation that sets the whole thing up, and then after that, it's just the normal Spring integration annotation or programming model. You could use XML if you wanted to. Nobody has to use Java config, right? You could use XML if you wanted to. Another one.
We got that on recording there?
Yeah. Why would somebody want to use the actuator endpoints for anything that actually didn't expose a web endpoint itself? Yeah. Well, like I said, I think it's optional. We chose to include it in the starter. We might choose not to when we get to GA, I don't know. For me, it feels natural because, you know, if I've got a process running in production, I need some way of introspecting it. I mean, so maybe JMX is, you know, the sort of go-to standard. That's always available. So even if you don't use the web bits, you can use the actuator and JMX. So I think I'd probably always want that information. So actually, it's not compulsory at all. It's just that we included it in the starter. And if it's in the starter, then it activates itself. If you wanted to, you could just add the Spring Cloud Stream dependencies on their own, and they don't have a dependency on the actuator. It's only the starter that we're using to build the samples. Can you add a what? Oh, yeah, right, okay, so Gary's saying, yeah, so Gary's just telling me how to fix that problem. So if you wanted JMX but not HTTP, then when you do spring application.run, then you can just set the web environment false property. Or server.port equals -1, says Eric. Yeah, these guys know it better than I do now. We got anything coming out?
It's there, yeah. You've been talking this whole time.
All right. Hello, Eric.
So yeah, basically we sent a message, as you can see down here, to the HTTP sources endpoint on my instance of Cloud Foundry. And then this is tailing the logs of the log sync in that same space. And we get the output there, system out.
Cool. Shall we
It's on the cloud. And
take it to the bridge?
Sure. I
James
guess
Brown would
there's
say.
a couple slides left, but this could tee up the session tomorrow. Just a couple last points here. This is relevant to, especially to the new Spring Cloud Dataflow model, this XD 2.0 basically. We have this module, well, this component called Module Launcher, which is actually just itself a process that can launch boot applications. It can do modification to the class path before it launches, so you can add things, you can substitute things, you can replace the binder. It also has a resolver strategy that will actually retrieve the jars from a Maven repository, which you can point to any repository you want. For XD, or Spring Cloud Dataflow, we're pointing to the module repository, or the Maven repository where the modules I just showed are being hosted, so Spring Cloud Stream modules with the ones that we've ported so far. But you could point to your own internal Maven repository and then just bring in the modules that you want to use and add your own custom modules there. It also falls back to the local repository. It's using the Eclipse project, the Ether project for that. On the bottom, yeah.
This module launcher is actually part of Spring Cloud Stream, right? Which is why it's
Right.
in this tool.
Right. You can run Java -jar on the module launcher, and then you specify a boot property to it of what the coordinates are, the Maven coordinates of the actual module that you want to run. So it gives you that level of indirection. And we also have a Docker image for that. So that you have a single Docker image. Instead of having to create Docker images for all of your individual modules, you can run this Docker image in an environment like Lattice, where you can support Docker containers, and you just have a single artifact, but it itself is resolving the jars. It also allows for the direct binding that I mentioned earlier. So in this case, we can have the source and processor sharing a channel, so there's no overhead there. There's no serialization overhead. There's no network overhead. But you can also have in this case, it's a stream source processor sync, but there is an external channel between the processor and the sync. This is just showing the components that are in the Spring Cloud Dataflow project now. So this is the top layer of what was XD. As I said earlier, the shell and the UI are still supported by that. The actual UI code is directly copied over from XD 1.0 for this. And the same shell commands are supported there as well. It's a subset right now, but all of the stream commands are supported today. So you can create streams, deploy, undeploy, and destroy streams. It's using the same DSL, so it has the parsing code there, as well as the ability to store your stream definitions, which is obviously another value add of this layer, to be able to record that. And then on the bottom, where it used to be communicating over Zookeeper with the XD containers in that runtime, it's now just delegating to a module deployer SPI, which is about 5 methods that we have to implement for different runtimes. And in every case, it's just a matter of telling it what the module coordinates are for a boot jar and the list of environment variables or the boot configuration properties that you want to specify for the connection of the channels and the partitioning and anything else that you've done in a much more concise way through the DSL. And so we have support for local deployment within the same process, as well as Yarn, Cloud Foundry, and Lattice. And all of these will be demoed tomorrow in the 8:30 session that Patrick and I will be doing. And this just shows what it actually looks like then. So Dataflow sits on top of the module launcher, basically, if you're running it locally. You can start up the admin, and then you start up the shell, and you point to your admin, whether it's on localhost or on Cloud Foundry or on Lattice. You simply do admin config server and give it the location, and then you issue commands against that. The admin jar is itself a boot application, and it has the same auto profile activation. So if you push it to Cloud Foundry, it activates the Cloud Foundry profile itself and wires in the Cloud Foundry deployer. If you do LTC create with the Dataflow admin, which we provide as a Docker image, then it recognizes it's running on Lattice, and it creates the Lattice SPI instance. And so that's how that works, and I think I'll skip that demo since we'll be doing that tomorrow in the 8:30 session. And I think we're down to the last few minutes, and I know that the reception is starting after this. And I heard applause in the next room already,
Yeah,
so
don't hold anybody
I don't
back
want
from
to,
the beer, do we?
get in the way. So.
Yeah. So thanks,
Any
everyone.
questions?
Any questions at the end? Just beer, right?
Okay.
Yeah. Good choice.
Okay, thank you.